Welcome, everybody. And members on Zoom, you are missing out on a rainy morning, and I think that's okay. I understand that yesterday night we had a little bit of snowstorm coming in. So our winter is arriving or has arrived. December 1st is the official start of winter, so it's today. You know. Yes. So my name is Ranu Jang. In case you are members on Zoom who don't know who I am, I'm at the University of Arkansas. I'm associate vice chancellor here, but most importantly, the director of the Institute for Integrative and Innovative Research. If you have not yet heard, we are IQBR, and the three superscript. And this is a new institute that was formed, and slowly that new is going away, but it's still quite new. But a very unique kind of institute where the university has set up an entity that spans the entire university, all the colleges, all the departments, but very unique in that it is not just a research institute as a traditional research institute, but we are a dual report to both research and innovation and economic development. So in our mission, part of our mission is not only to support enhancement of research, but to support economic development in the region. So actually, we are part of a bigger puzzle of how do we grow Northwest Arkansas, and whether it is the culture, whether it is the art, or whether it is the higher end technologies that might happen, or how we might support not just Northwest Arkansas, but our Arkansas itself, and then be able to have a growing wheel of impact. So how do we do that? IQDAR has taken the approach of saying we are going to solve wicked problems, problems that don't have easy answers, cannot be, need lots of partnerships, need lots of connections, need you to take risk. And we will do that in the format of addressing grand challenges. And one of our the initial grand challenge we have is integrative health. And under integrative health, we are combining. Health is not just about health. It is about socioeconomic stuff. It is about policies. It is about politics. It's about all of that put together. It's about behavior of people. So what we're saying is, how do you merge together the food tech, health tech, cyber operations, all pulled together in order to be able to give us good, healthy well-being? So there's 5 words, if I can say, you can remember about how we're approaching that. And one of those words is specifically related to the topic here, is convergence. And when we talk about convergence, we're not just talking about convergence across disciplines, but convergence across sectors, which perhaps is obvious if we just talked about how you need to bring all of these things together. Integration of ideas, integrations of subject matter expertise, all of that put together. Innovation, economic development, and then the word at scale, because that is what we want to be able to do, is take whatever we are solutions we come up with, problems that we are addressing, whatever we come up with here, that we can move it out to be at scale. And so keeping that in mind, IQTAR is really thrilled that we have got a dream team here, which is pulling together convergence research. They are going to talk about that today. I expect there will be a lot of panel discussion about it. And I'm not going to steal their thunder and tell you what they're going to talk about. But this is a perfect example of what we think about when we think about IQTAR's current and future impact, and the trajectory that we want to go on. So with that, welcome everybody. There is one more morning seminar that's going to happen next Friday. I think 2 or 3 of our doctoral students are going to tell a little bit about what's going on with their research. And then, if you haven't noticed, today we just announced our Inspire Fund. It's a giving fund for IQDAR. We just launched that, and what we have decided is that every year we are going to take on something that we are going to say the fund is going to be raised for achieving this. So every year it might be different, but this year what we have said is that starting January 2025, we want to use this Inspire Fund to support undergraduate research. We have had fantastic undergraduate students, a few of them that have come into the labs here, but any undergraduate student across the entire university who could be could be funded through this. There's an application process, etc., etc. but this fund will allow us to do that. So if you are interested in giving to IQDAR, which we hope you are, and that this is where next year's funds will go, and of course they are tax deductible. So there's still time to do to do that. All right.
Where can folks donate?
And the folks can donate if you go in on the link on the university link itself for giving. And if you open Arkansas News today, there is a little article and you can link there itself. But you can choose IQDAR's Inspire Fund under other. And then you can give from there. And you can use your credit card. You don't have to write a check. You can just put in your credit card.
I believe for those watching, there is a QR code that was on some of those walk-in slides. So if you rewind the video a little bit, you can have
reference to that. Okay, great. That would be fantastic. All right. With that, and Happy New Year, Happy Holidays to this group and to those on listening on Zoom. And there you are.
Thank you, Dr. Young. Hi, everyone. I'm Philip Temple, project manager here at IQDAR, and have the great privilege of not only leading this discussion today, but also working with this amazing team on a Cultivate IQ project, which is a National Science Foundation Accelerator project. As Dr. Jung mentioned, the convergence concept is bringing together multiple disciplines. Each of these folks is only about skill set and knowledge base that they bring to this project. And great to start with our principal investigator, Dr. Meredith Adkins, and go down and move around. So just please introduce yourself, your role, and what you're doing on the project.
Okay. My name is Meredith Adkins. I'm an IQDAR assistant research faculty. My field is public policy and community development. With this project, I am maybe the only social scientist on the co-investigator team. And my role is really the kind of the cloud around the technology development project. So what's the societal need? What's the impact? What are potential barriers to deployment? And so during this past year, it's really focused on user discovery of the product that we're developing through the Convergence Accelerator. And so that's entailed a lot of just interviews with stakeholders, with potential end users to just understand what they need, how we can help them. And that is really something that social scientists are trained in needs assessment. And so that's kind of the main thing that I've led. And then the second hat I wear is really the team coordination and partnership building. So being a research faculty is new to me. I actually spent the last 10 years in economic development, mostly doing industry relations. And so in that role, I network. That was my function, was to network. And so to build this convergence team, I basically networked. And I found industry partners like Kim, CEO of Curate, Advanced CEO of Junction AI, that are here today, and then various faculty. And we just started talking about what skill set each person could bring and how the academic side and the industry side could come together with a real societal need. So that's kind of fun.
I'm Jack Coffer. I'm professor in the Geosciences Department, the director of the Center for Advanced Spatial Technologies. And our role in this is bringing data together that can enable some of the goals of the project in ways that haven't been possible in the past. There's a wide range of imagery available from satellites, from aircraft, and from privately operated drones, all of which can play a role in bringing together small community farmers and allowing them to enter into the larger markets in ways that really haven't been possible without that. So monitoring in ways that they haven't been able to, understanding their crop health, but also allowing that to be collected and explored on a larger scale. And then managing all of that data is in itself a difficult problem at times. And so we're here to bring our expertise into the project and help them forward.
All right, I'm Laura Bucket, and I'm a member here at the Institute for Integrative and Innovative Research, and my title is Associate Director of Digital and Creative Services. part in this project is really to act as creative director and to help guide the team to create effective materials to tell the story and help sell the idea that is Cultivate.
Hello, my name is Dr. Kristen Gibson. I'm professor in food science and I'm the director of the Center for Food Safety within the University of Arkansas System Division of Agriculture. I've been here for a while and most of my work is centered on food safety related to specialty crops, specifically fresh produce, getting into a little bit of value added type food safety issues. I am a microbiologist and I do study mostly foodborne viruses. As far as this project is concerned, one area that I do focus on a lot are the regulatory areas related to food safety and specialty crops. So way back, FSMA was passed, and part of that was a produce safety rule. And so when we think about people or growers entering new markets, we have to think about the regulatory implications or the needs of the buyers and what the growers are able to accomplish. And so some of them may have barriers meeting those regulatory requirements or the requirements of their buyers. So I'm here just to understand and provide that subject matter expertise and those food safety regulations that may inhibit these target growers and farmers that we're trying to reach into entering into this new market space that Cultivate IQ is supposed to provide.
Hi everybody, I am Meredith. Today serving as assistant professor in the BECS department. My background is machine learning and computer vision. I got my master and PhD at Quality Learning University in 2015 and 18, respectively. And I joined the university in 2019 after 1 year in Moscow. And currently, I already step lab in artificial intelligence and computer vision for about 4 years. My primary role in this project is to begin the development of computational model for understanding and analyzing the data from ground view into drone views and satellite sources. And I have worked with Dr. Jack Cochran a lot in understanding and how we utilize the satellite imaging or the drone video-based better in order to support farmer and the people better in not only get to know about the current status of farm, but also monitoring and predict for the future agriculture development better.
Yeah, my name is Trey Malone. I'm an agricultural economist. I actually wasn't on the phase 1 proposal, but I'm kind of stepping in this spot to kind of continue. I've got about a decade's worth of food systems research and outreach background. My current role is pretty heavily focused on entrepreneurship and innovation in the food system, kind of with a heavy focus in the state of Arkansas. I think everybody here probably knows that Arkansas is the #1 food insecurity state. It also just came out last week that a pretty thorough review put us as the #1 food waste state as well. We are also considered one of the most important agricultural production states. So when you think about this kind of at least perceived paradox associated with having the #1 largest grocery outlets and all of the CPG companies here in Northwest Arkansas that could play this really important role in addressing some of these large wicked problems that we have in the state of Arkansas. A project like this and convergence research like we're talking about is something that gets me really excited. And it's something that I'm really thrilled to be in the state of Arkansas to be working with this kind of rock star group of players to address some of those problems.
And founder of Curate, and we exist to shift dollars back into our local communities by building an empowered farm and food supply to meet a change in this consumer demand landscape, that through entrepreneurship, education, and local procurement. So my expertise at this project here is that we actively purchase for institutional food service right now and integrating farm and food products into those institutional food service areas, including retail and back of house food production. So because we're actively doing that sourcing on an ongoing basis, it helped here in this project.
Thanks so much. And this big team of experts in a variety of different fields in business, economics, and science, imaging and analyzing satellite images using another member of the team who's not here, Vince Ruby from Junction AI, which is an AI software development firm. Have come together to solve the wicked problem that is local food as it's grown here in Arkansas and Northwest Arkansas in particular has one of the highest ratios of small farmers in the state. Ag is the #1 industry in Arkansas. We are the #1 exporter of broiler chickens, of rice to the rest of the world from U.S. states. And we produce a lot of food domestically, especially for animal feed. That said, the local food that we are growing here is largely unavailable in grocery stores to large food distributors, where, as Kim mentioned, the demand, and I think many of us in this room and probably on Zoom would be in this category, are looking for local, are wanting more fresh, healthy food. And as Trey alluded to, food insecurity is very high in the state of Arkansas, and at the same time, they're wasting a lot. So this group came together for the National Science Foundation Accelerator grant, try to develop a solution to these problems. How do we connect local growers with market opportunities? How do we make fresh food more available in our communities, schools, institutions included? And how do we reduce our food waste, particularly from the production? A lot of food waste is food loss, is stuff that's never harvested, never gets out of the field. So I'd like to turn over to Meredith, and if you want to say anything more about the Convergence Accelerator program or where we are in the development of Cultivate IQ's software platform, and then we'll show a brief video that was created by Laura and the creative team to try to communicate this to the general audience.
Great. So I'm not going to give the 10-minute pitch that we gave to NSF. We worked on that for like 6 to 8 weeks, many revisions of the slide deck. And so I'm just going to tell you a little tiny bit about what we've done in this first year of the project. So as Philip said, with this project, we really set out to understand if we could make market data, supply, demand, consumer insights, if we could make it more accessible to the small farms and food businesses and regional food systems. Could we support the retail value chain to put more local food on shelves in our communities, on institutional shelves, such as our supermarkets, grocery stores, restaurants, hospitals? And one of the kind of impetuses behind that was we saw that in the Walmart vendor world, which, as everyone knows, is very heavy in Northwest Arkansas, we saw how much data was really driving the buyer-seller relationship and how sellers could really be empowered in that relationship with the buyer by showing the consumer demand and having the right product that could meet that demand. But there's been a lot of efforts to get this data to smaller farms, small food businesses, but they don't have a lot of time, and it can just be a lot of data coming at them that actually in one of our interviews, one farmer said, it's just gobbledygook. I like that quote. And so with AI, it's really revolutionizing the data world, but what it's doing with streams of data, particularly lots of different streams of data, is enabling us to make it much more simple to actually not actually need that business analyst and be able to produce neat insights for a particular field. So not for like your Kraft Homes, macaroni box, but for these specialty crops, vegetables and fruits and regionally produced proteins. And so that's really what we set out to do. And the Convergence Accelerator grant, I just wanted to say a little bit about this grant because it's brand new. So it's out of the National Science Foundation newest directorate in 30 years, TIP, Technology Innovation Partnerships. Their largest grant program is NSF Engines, which is a $50 million grant to build full innovation ecosystems. Convergence Accelerator is within that same directorate, and it's really focused on enabling faculty to get more involved in translational research. So to get research out of the lab and into society. It really prioritizes what several people said today about convergence research, because complex wicked problems need lots of different fields coming together. And so that's what it enables. And the phase one of Convergence Accelerator is really about exploring your idea, your concept of what you wanted to, what product you wanted to build. And so really the past year has mostly been focused on user discovery. As we mentioned a little bit earlier, it's really been focused on understanding the audience and what they need, as Vance likes to say, what hair on fire problem we can solve, what are their pain points, and then how can we iterate our solution so that it better fits those needs. And so, our original idea is still within this platform, certainly, but also throughout the year, we've changed it. And we've brought, as we're continuing the project forward, we've brought in new angles, more ag. We needed more economics expertise on the project. Clearly, has a lot of economics in pieces. And then we also we wanted to move away from sort of some of the on-farm type monitoring that we were looking at originally, so that we could look more at the regional food system. And so we were able to bring in, with Nancy's partnerships, bring in the geospatial aspect with CAST. We've also, as we're moving forward on the project, we are also bringing in University of Wisconsin, where they have a lot of expertise in profitability, so that as farmers are looking at what products they're going to be able to sell to institutional buyers, also what's going to be most profitable for their businesses. And so it's been a great experience with the user discovery, and we're applied for funding to keep the project going, and are just looking forward to actually building the technology as we think.
Thanks, Meredith. And Jillian, if we can go to the video, I'll play a short video that tells us more about Cultivate IQ, product under development.
1/3 of food produced globally for human consumption is wasted each year. Weather events and climate change, pests and diseases prevent 30% of global food production from entering the farm-to-fork supply chain. Supply chain inefficiencies result in the loss of 14% of the global food supply. United States households waste 35.3 million tons of food each year. Northwest Arkansas's regional contribution is over 1.1 million pounds. The story is similar in regions across the U.S. In developed countries, fruits and vegetables account for most of the waste. There is a solution. Cultivate IQ, empowering regional food systems.
We always say that COVID-19 didn't break anything, it just pulled the blanket back and revealed on what was already broken within our food systems.
Global food disruptions from climate change, from the COVID pandemic, have showed us how fragile the global food system really is. It has displayed how important it is to create robust, regional, resilient food systems.
Small and mid-sized farmers have a really hard time growing. They have difficulty accessing land, they have difficulty accessing labor, they have difficulty accessing financing to grow their operations. What Cultivate IQ will do is enable them to more efficiently work with their existing partners, distributor partners, food manufacturers, etc., and to more efficiently grow their business.
What we're doing with our data-driven systems is we're providing those small and medium-sized farmers with what's going to be needed based on our forecasting and our artificial intelligence systems, so that they can map their operations in a way that stays ahead of the game, and instead of being reactionary to the game. And that'll put them in a better position, as well as those that are trying to finance them in a more risk-free position to be aggressive in these relationships.
Food safety is a really big part of regional and local food systems. So the ability to develop those food systems really depends on the safety of the food that's being produced and whether the growers are able to adhere to the regulations that apply to them. But if they want to sell to certain buyers, like an institutional buyer or a grocery chain that's really large but wants to use local products, they will have to comply.
In my experience, when small farmers and producers are starting out, they're going based on what they know. And so if you're not born into the right network or you don't know someone you don't know, then it's hard for you to be able to uncover those additional data points. Our industry expertise is really in food systems and institutional purchasing. We hope that there's a larger impact for those growers and producers to be able to reach more customers.
Cultivate IQ is addressing this by matching supply and demand so that farmers and other food producers aren't overproducing products that people don't want to buy and are producing the products that they can sell.
With the concentration of producers in Northwest Arkansas and Eastern Oklahoma, there is no reason why we shouldn't be able to eat locally, source locally, and make sure that those dollars stay within our regional economies.
Our mission is to empower small to mid-sized farmers, ranchers, and local food buyers to optimize production and institutional sales through accessible data insights and decision support tools that grow the local food-to-market supply chain.
So, addressing food loss is in part trying to address this fundamental mismatch of data, or at least perceived data from the producer supplier side and the end consumer. You have to keep in mind that only about 18% of the food expenditure that you make actually goes to the farmer. So there is this massive disconnect between what the farmer receives versus what the end retail user pays. And within that gap creates so many inconsistencies in data that I think Meredith can talk about the importance of trying to address those data inconsistencies.
Yeah, so I think I'll highlight two things. One is really the priority that Cultivate IQ places on forecasting. So not just, what are prices right now or what's demand right now, but what can we see over time, and how can we kind of have a better idea of what demand's going to look like next year, even for a purchaser who, for example, if they had more peaches last year, they could have sold them, and so they should have bought more peaches from their farmers. So just understanding over time all of these different categories and be able to forecast. And then also, and try to touch on this as well, also the profitability. So there is typically a much lower price for wholesale as opposed to, say, a farmer's market or direct to consumer. However, a lot of times they're talking with the extension support, folks working with the farmers. When you really do the calculations, a lot of times a larger volume of cells with a lower price actually, looking at all the inputs, it actually can be more profitable. And so adding in that profitability piece around really understanding not only that just that there's a market opportunity. Second, is it relevant for my region? So not just national. A lot of data that's available right now, it's national level data. So regionally relevant is also really important for us. And is it good for my business? And then the other thing is, in terms of who is this data going to, we have definitely focused a lot on farmers throughout our project. But throughout this year, we also sort of pivoted a lot more of our focus to local food distributors, because they play a really central role in kind of this intermediary role of building the relationships with the institutional buyers, building a relationship with the farmers, and then also to kind of play that supply demand efficiency role of, we need more of our producers within my full supply chain to produce X, because I have institutional buyers to to do that. So really our software at the end of the day is helping those food distributors to do that in communication with their partners. So ultimately we determined that our end user, which is a really big part of user discovery, is who is your end user. Our end user for the platform will be primarily food distributors, potentially government agencies as well, and then that they would onboard their farm supply network to have access to this data as well.
Okay. Can I interrupt and ask, perhaps you can explain to us a little better what is meant by institutional buyer versus food distributor? And what is a small farmer?
Okay, yeah, that's a great segue. Because Kim, I was going to say, as someone who buys to institutions, acting as that distributor, that intermediary, can you talk to us a little bit about what small farmers struggle to do in terms of predicting demand and what institutions are looking for and why it's so hard to connect? Yeah.
So an institutional buyer would be anybody in a food service capacity at universities, hospitals, convention centers, corporate cafeterias. But in this case, we're also looking at the grocery side of the supply chain as well. So there's two ways in which you can look at food service, or food for retail, where you're going to the grocery store and buying it direct to their consumption that way. So both are channels that are being explored in this context. In order for food to get to those places, someone needs to typically put it on a truck and bring it to those different locations. And that is oftentimes a distributor who's aggregating and then driving that product to that location. There are also companies like ours who ends up being the aggregator of product, but just through purchasing. So we don't actually warehouse and drive any product on a truck, but we are doing the purchasing on behalf of institutions to buy the things that they need. And in our model, the farmer actually direct delivers or directly ships to that institution. And then that small farmer or producer is that person growing or producing that product that needs to be brought to market, ranging from lamb to blueberries to, you name it.
What's the size of a small farmer? My backyard beds or
Well, from a food safety perspective, you don't want any backyard farmers chains.
Yeah, if you go to the farmer's market, you probably do so.
Well, I would say, you could get a lot of produce even from an acre.
Yeah, there's a few ways to slice what small farm means. The USDA's definition of a small farm is, I think, anything under 180 acres, which is a lot of land.
Actually,
in Arkansas, actually, less than 2% of farmers are specialty crop farmers. Fruits and vegetables, nuts, the things that we eat and buy at the grocery store every day, what we think of as produce. But small farms can also be thought of as under $1 million in annual sales. I think that's a little more consistent with what most of the small farmers that we think about and that we work with are the kind of scale that they're at. And that represents almost 90% of all farms. So most farms in the US, the vast majority of them are under 100 acres, under $1 million in sales every year. And so it gives you a sense of most of our food is coming from a lot of small farms that someone is aggregating that food and then distributing out. So it's sort of a wide base. It comes together in these points and then it goes out to a wide number of buyers, like these institutions.
So if you go by the FSMA produce safety rule regulatory definition,
and FSMA is
Food Safety Modernization Act, and the produce safety rule is one of the rules that was it's being implemented in that act. So the definition there, a very small farm, and they're not basing on size, this is profits and revenue, is under $25,000. That's a very small revenue, yeah. So that's a very small. So they are from only the produce that falls under the rule, right? So they may have other endeavors, And so that's a very small one, and they're exempt from a lot of these requirements. And then you go up a tier to small, and I don't recall what it was, but I think it's like 250,000 or yeah. So I mean, so it's even less than the $1 million mark when you're thinking about that definition. And then I can't even get into the complexity of local and regional farms not even being covered by the rule, depending on, you know, the circumference from wherever they're selling to. So I mean, there's a lot of nuances to that definition. So it's very difficult to define what a small farm is.
And I think there's a good thing to emphasize here is that you're talking about revenue. You know, I think everybody, when you say small, large, you immediately are attracted to thinking about this in terms of geography. But it's kind of a misnomer. So for context, my family has a ranch in Oklahoma. It's in the panhandle of Oklahoma, which is essentially desert. It's 1,000 acres. That sounds like a big farm. We can run 50 head of beef cows on that farm. On 1,000 acres, that's all we can actually have in terms of capacity. That is not a big farm. But it sounds like a big farm if you just talk about acreage. And so when we're talking about FSMA, for example, what we're actually talking about is revenue, because I imagine what a 1,000-acre mushroom farm would look like. Like, that's so many mushrooms. And nobody needs a 1,000-acre mushroom farm. But that's not the same thing. And so when we're talking about like the complexities of these small systems and the need for some type of convergence data platform, this is exactly what we're talking about, because it is hyper complicated when you are on a specific producer's farm to try to advise them what they should do. I can't walk over to my granddad, who's an 85-year-old rancher, and say, you know, maybe morel mushrooms are the thing that are going to be your profit maximizing choice. Because who knows? And that's what's exciting about this type of project.
And also, oh, sorry.
No, please go ahead.
Okay. So there's also such difference between green beans versus onions versus blueberries, right? Each type of specialty crop has a different shelf life, a different way you harvest it, a different way you package it. So even just saying produce is also way too large. And so it's both local and regional food systems and down to the product type, of which, you know, you don't need 1,000 acres of morel mushrooms, but maybe you do of your more, you know, household. Yeah, right, exactly. And the other thing I was going to just chime in about food loss quickly is that many of our small farmers will go to farmers markets, and instead of seeing things they don't sell at that market as an opportunity to find an alternative sales channel, they'll throw it away or just donate it. And I'm not trying to say like, stop donating food. This is, you know, yay for our food banks. However, could we see that as another opportunity for a sale, as opposed to you getting $0 for what you don't sell at the farmer's market? So that's a big mental shift that has to happen, because most will just come and be like, oh, I don't want to haul this all the way back to my farm. And it's already picked from the ground, so immediately time's ticking as to like when we can actually consume that before it spoils. Highly perishable products, you know, you gotta move them fast.
And if your head is spinning with all these definitions and factors and things to think about, now imagine you're a farmer dealing with the weather, and you're dealing with, you know, all of the practicalities of growing this food from seed, from the start to a harvestable product, and then you get that harvestable product, and you have to also figure out where I'm going to sell it to, how am I going to price it? And so part of the Cultivate IQ platform is to think about, as we talked about oversupply, and as an example, hey, there's a market here. All the farmers rush to grow that thing that there's a market for. Then you've oversupplied, the price goes down, you can't sell your hemp or blueberries or morel mushrooms for the price that you thought you would. You're now losing money, and you have a really difficult choice of, do I sell this at a loss, or do I not pay someone to harvest it, not pay to deliver it, and just till it into the ground and grow something next year? Donate it is a great way, but that also requires additional expenses. So Neon and Jack, as part of this team, one of the things that I've learned in this project that I really didn't understand and have been amazed by is the capabilities just using, what's basically publicly available satellite data to determine what's being grown in the field across the region, and what state that harvest is at, pest pressure, disease pressure that impacts the funds as they run through the year. Can you just share with us a little bit about what the capabilities are today that I think a lot of people don't appreciate what we can learn just by looking at satellite data, image data of this region or a specific plot, and how we're proposing to use that to help.
Sure. So I think that we turn to geography a little bit and the size of the farm, because I think this matters here. We have a long history in the U.S. of being able to monitor crops at large scale, regional scale, national scale, on a global scale, at relatively what we think of as low resolution. So we're only getting samples on the ground that may cover 1,000 square meters or so. And so it's an aggregated sample. And for these large, and I can't remember what trade called them, but the corn and the soybean and rice and those large field those commodity products that those are relatively easy. We have very good ideas of where and how much produce is going to be produced at any given time or at any season, and have historical data to look at weather patterns and diseases and understand that process well. That doesn't apply necessarily. It doesn't scale to strawberries and blueberries and morel mushrooms and kinds of things that we're talking about here that would be supplied on a regional basis. And so I think it is still an unknown. It is still a question of how to economically and at scale understand how many blueberries a small plot is going to produce across a region. So we look at the other side of the problem, which is the institutional buyers, the food producers or the food retailers, or the distributors perhaps. They're signing contracts to provide so many blueberries or strawberries to a particular institution. They have to have confidence that they will get those, fulfill the terms of the contract. And often that pushes them, I think this is right, pushes them to larger growers, national growers in California, Mexico, wherever it might be, that have that have those 1,000-acre plots of mushrooms that are growing, and they have fairly good confidence that those will be delivered. But if they're pulling together small farms, any small group of those that fail to produce a crop or to produce at the scale that they contracted with can create a supply problem for the institutional buyers. And so while they can contact farmers and the farmers can say how much they'll produce, often I think they'll probably need a third party, unbiased, assessment of what that overall productivity will be. And that's where I think we come in providing a way to do that. And instantly, I think in this world, your mind goes to drones and monitoring drones, but drones are expensive, and don't let anybody tell you that they aren't. Operating one is at that scale, especially when you're trying to operate 1,000 of them over Northwest Arkansas. It's just the logistics involved in that are very difficult. That doesn't mean they don't have a role, but in monitoring on a large scale, it's far more cost effective to look at larger airborne imagery. But flying an aircraft is expensive. And so this is where we're looking at satellite imagery that is not available through government sources, because what's available at government sources is that large national scale work with very large ground samples that don't really help much in these small fields. Higher resolution imaging satellites are available now. They are becoming more cost effective. You can have samples now that are maybe 3 feet by 3 feet on the ground rather than 30 meters by 30 meters on the ground. So this is a scale change. And so what our effort will be is to look at whether or not we can economically get access to that imagery and use it effectively using these new AI techniques that Dan is developing to get a better estimate of what this large scale productivity would be and give the institutional buyers confidence that they'll be able to contracts and at the same time benefit farmers who will be able to sign the contract.
Can you share with us a little more about the AI, the ML, how you take that data, say you have a 3x3 square, that's a pixel and that scale, but just help us understand what you can do with that.
So first of all, before answering the question, like in the beginning of the project, actually we define the farmers as the primary user. And at the moment we start, learning and collecting data from the ground. Like with the phone, you can capture, the tree or the plant and analyze, for example, other disease or counting how many fruit on the tree, thing like that. So we spend some time, and to get along with that, we have the many other interviews with the farmer and the products. And after many analysis and understanding the demand together with the limitation of the current technique on that kind of task, because analyze the ground data have a lot of challenges included, like pollutions, illumination from the light, that you capture some plant under the cloudy day different from the bright, sunny day. So that's why, the target on satellite regimes come like few months after the first round we work on the ground data. And working on satellite imaging is very different from other computer vision tasks. Even like our lab, we have many years working on different type of data, from the face until seeing understanding for autonomous tasks, until develop other tool for the small plant processing. However, working on satellite imaging is very different. The first task have to understand how to apply the data, and then to Jack and other people at the task center, we are able to apply the data from both resolution, low resolution into free sources. From many satellites, many orbits. However, with the high resolution into one, we really want to get, because low resolution from free sources is very hard in order to understand the detail. For example, like Jack said, the free sources you have to read 30 meter, and doing by that way you cannot identify the disease or some fungus happen in the farm until it already spread a little bit big. And that's why we come up with one is the commercial satellite sources in order to get better resolution of the drone base. And in terms of the next movement, we would like to support the farmer better in terms of monitoring the farm and predict the plant development or the harvesting. So I don't want to go very deep in the machine learning side, but talk about the technique nowadays. Like for example, in our research, we have a bunch of research having published in top tier conferences and journal in the field that related to like understand the low resolution image and reconstructing to the higher resolution and better understand the detail there. Or we also have a bunch of other things in order to do segmentation, especially target on the boundary. Because the farm, when you would like to localize a particular crop, the major concern here that how can you are able to distinguish some, it's not exactly the crop, it's just the border between the field. And under the satellite view, it's actually a very tiny thing. So understand the boundary, that detail. We also have the many techniques that we have successfully applied in medical imaging. So that you would like to segment the brain tumor, when you would like to distinguish the tissue, very weak boundary object, things like that. So we would like to extend that type of technique in order to localize the crop better. And based on what we localize the crop here, we can, develop further with other classification tasks at the pixel level in order to understand the type of crop that people grow in that field. However, the good thing in our research that we have many research developed in terms of time series or video understanding. Because like the satellite images go around the Earth, even the same locations, it's going to capture multiple times during 1 month. So think about it, a year, you are able to acquire the time-lapse data of particular crop. So the thing we are doing in that we're going to check the time-lapse data in order to monitor the farm and also predict things in the future better by on the time-lapse. However, in order to do that, like Jack might be understand it better because the normalization and align with image is very painful. Because the one it go around look exact, very similar location, but actually it's not align exactly the location you want to. So aligning data and take into account the time lapse information is very helpful in order to support the farmer or the food herb in order to monitor what's really going on in the farm, how the development progress, and how things going to happen in the future for your crop or in the very big area. I would say.
Yeah. And so you're saying take that time lapse data, understand what is growing in the region, matching that in the platform with data that we're getting from distributors and food hubs to understand what's selling, so that we can say, hey, there may be a demand for onions, but there's also a lot of onions being grown in this region. You may want to look for another crop that has demand that is not being met or can get a higher price. And it is hard to describe this and communicate all of the aspects of the market challenges, all of the aspects of the product that it's trying to do. And Laura, I want to give you the last word here with, help us to understand, the strategies that we saw, in this video, but also communicating science and communicating research that is multifaceted, that is complex, that is, challenging for the researchers in this field to figure out. We're trying to push the boundaries of what is technically possible. And then you have to go and describe that to someone with no technical background, whether they be a farmer or a food hub or an investor in this product. What strategies do you use, and what are the kind of approaches that help to get those messages across?
Yeah, thank you for that question. Is in user experience, and I think that this team, as well as the National Science Foundation in general, as far as creating this project, setting up how we're going to make convergence acceleration, right? They have evangelized design. They've evangelized the design process, the design thinking process, which you guys are doing as you're doing your research and getting this quantitative and qualitative data on your users. Everything is about the users. And of course, it's incredibly complex. Everyone in this room would probably, has anyone ever been at the dinner party and you tried to tell someone what you do and eventually they just glaze over in about 15 seconds, right?
Yeah.
And I think when I was an engineer, they would laugh and they say, I have no idea what that is. And so if I've learned anything, and my favorite thing to do is work with scientists and people in research, because I believe that it really is, if I dare say that I'm someone that is in marketing, it is a way that marketing can change the world. But we don't want to be so verbose. I think everyone in this room has probably heard me say, make it shorter. What's the point? What's the who, what, when, where, why, and how? But really think about, if you are in an elevator with someone who could be a potential client, who could be a potential user of this product, how do you get the idea across that you have something valuable in 15 seconds? And that's a designer, a user experience, a creative director's job, is to understand, empathize with the audience. It's incredibly helpful to have clients that have already done the work to understand their audience. And then we define the problem, right? What is the problem? And then we question all of the assumptions, which is my favorite part of the design process. And I have to say it, because that is the point where I think in design, designers suggest can often be taken as something that is from an ego,
and not from an area of subject matter expertise. I promise you, the designers exist to try and help you to understand your problem. And even though you may not understand why they want to take your 4-page document and turn it into a sentence, I promise you the ultimate goal of working with creatives is to make your ideas understandable to anyone and to bring feeling to that. I hope that everyone is able to watch that video and feel how this is going to help someone. Feel what that problem is so that you care enough to even want to solve it. And if you can get people to care about your product, then they will use it. So I'm incredibly grateful for everyone in this team and for the National Science Foundation for setting up the steps to help prepare you guys for a successful launch. And also for the team for understanding that this is an iterative and collaborative process where when we had to move, we all had to move and do things. It was wonderful to go back and forth with ideas. And me, myself, as a designer, was so excited to hear that from scientists at the NSF that were reading through and helping craft a presentation. Even they said, that's gobbledygook. It's too much. Make it simpler. And so I like that. Your presentation should be in addition to what you're saying, or, it shouldn't be everything on the page, right? It's there to bring more of an understanding. So I hope that I've done my part, and that everyone is able to understand in 3 minutes or in 15 seconds. I think if you ask anyone here now, we can tell you what it is. And then continue to craft and find that message as your company grows. Because, like I said, it's always better than always listening.
Yeah, thank you for that. And thank you to everyone on the panel for joining us. Keep an eye out for Cultivate IQ as we continue to advance this project in the years ahead. I just want to end by saying, join us next Friday, same time, 9 a.m. Here at IQ DAR, or on Zoom. We'll be featuring the graduate and postdoctoral researchers that are doing amazing work here at the Institute, and give them an opportunity to communicate the very complex but also really interesting and impactful work that they're doing here. And if you want to support those researchers, go to onlinegiving.ur.edu, put other department in the designation. Inspire Fund will help us continue that work. And thanks everybody for being here today.
I know. Do you have a question?
Yeah. Please stick with us if you can.
Before we take the questions, since some people might have to leave, I also wanted to say, believe it or not, this is not the whole team.
Yeah.
Also just want to recognize some people who weren't able to come today. Dr. Chase Rainwater, industrial engineering, is one of the co-investigators. Carly Huppet, Griffith, you saw her on the video, Indigenous Food and Agriculture. Initiative for Indigenous Food and Agriculture is one of our key partners. Dr. Marty Matlock, biological engineering and an expert in regional food systems, are also key players.
Question from online. With all the data input, satellite, drone, and weather data, what input we ask from the farmers themselves?
I have an answer to that, which is we don't want them to have to do any extra work.
Right.
We want to be able to provide them the information from what is out there and we can process without them having to do more. Because as you heard, they're already doing a lot.
That's right. And then one other thing I'll add, which I don't think it came out enough during the presentation, is that is one of the reasons we shifted from farmers as being key users and shifted away from doing a lot of on-farm tasks that would be too time intensive and went to the regional level. And then also, you've heard there's so many challenges in local food systems. A software platform can only do so much. And one of the key reasons that we're really focused on with local food purchasers like Curate and like food hubs is because they're addressing so many other challenges, from helping to aggregate product to meet the scale needed by larger buyers, helping to create the single purchasing, building relationships with institutional buyers, which farmers don't have time to be building all these relationships. So there was also a reason in kind of getting that workload down that we really just wanted the farmers to focus on what they're doing and their relationship with their key
close out for our online audience and thank everyone for joining us.
Thank you.